is Harish Kumar. This is my 6th session video. This video I am going to simulate SMPS, and this is my voltage testing. This entire video contains voltage testing method, how to trace by the voltage testing method. Okay, you can follow the SMPS. Back to the board. Okay, you can power up by powering this. So yeah, put it in your multimeter in AC. Okay, put it in your multimeter in AC and check the voltage, input voltage. Yeah, that's a 230. Yeah, this is your plug-in point. And from this point, trace out is, take it as a neutral as a reference and check fuse at a fuse. It's coming. Power start flowing, and then my next law point is EMI filter. It's coming, and then EMI output. Take your neutral as a reference and measure it across EMI filter. Okay, and then output of the EMI filter is, it's coming 230, and measure whether it's your AC going to input as input of the rectifier. Yes, it's going. Now measure your bridge output that you can't measure in AC. If you can try, let's see what happens. I think that's showing 698. That's wrong. You can't get it for a 230. You can't get a 698, right? You should put it as this in a DC mode. This indicates DC mode. This is AC mode. Come back to this and measure voltage. That's 370. Of course, it's a 317 is normal voltage for boosting capacitor. Okay. Be careful. It's a more dangerous. This is your DC bank. This is your DC bank across the capacitor. These two capacitors are parallel. Oh, not parallel. It's a series capacitors. Okay. So measure across one capacitor. I think you get say around 140 volts, and one more capacitor you get 160. So measure across the total capacitors. You get around 370. Okay, that's normal. This your capacitors negative. Is a negative. That means it's shown in a very thick PCB track. This is your hot ground. Whatever your voltage measure at the input side, you should measure with respect to your hot ground only. Okay, and my next test point is startup. This is my PWM IC, and then this is my startup circuit. This one. This is my startup circuit. Okay, I'm getting at the startup. Be careful. Yes, there is a voltage divider. Yes. Oh, sure. Oh, your output is around 13 volts, means it's a VCC is from 10 volts to 16 volts. That's normal. Okay, it's a pin number. Pin number 5. It's a pin number 5. 12 volts, sure. Okay, and the next test point is it your VCC? That means your bank voltage is going for your TX or not? Check it out. It's going. And the next testing point is your DC run circuit. This is startup and DC circuit move, both are together. Okay, this is your DC, the run circuit. Okay, and see that this is a DC run. This is a DC run. Okay, and this is my MOSFET, and please don't touch it. The surface may sometimes connected to their drain. That means that's a 400 volts. You can get shock. It's a probability. And then this is my opto oscillator. Okay, And then one more point is oh yes, almost 2 volts for your collector of the isolator. And then few of the test points is DC run, everything is okay. And these all are this is the feedback pin of pin number 4 is your feedback pin. That's you are getting negative, means that's where you are getting pulses that you can't measure in a IC. Okay, and then please don't measure, and very important point is don't measure your this TX AC voltage in your multimeter. Why? Means that harmful and that may affect for your DML. Why? Means there is you are getting very high frequency ramp voltage that may damages your DML. Why? Because means there is almost 20 kilohertz, 15 kilohertz limit of this your SMP. That means multimeter. So I told in my first session video itself, the SMPS operating frequency is around 15 to 50 kilohertz. Okay, you can't measure it in your multimeter. Okay, yeah. Come back to your secondary. This is your secondary. Okay, this is your secondary. And one more thing, in your secondary you should measure your voltage with respect to cold ground. This is cold ground. On ground you can identify very easily. That's a blind method itself. If any track is very big track is a continuous track, means that's a negative. I think so. This one. You are getting your output voltage around 10 volts. Okay. From this capacitor. Okay. This is your LC filter. This is a capacitor. Yeah, I think this is a 16 volts capacitor, and you should keep in your mind, this is the most important point, you always should put your capacitor voltage that must be greater than your coming out voltage. That means that should, I think so, that's a 2 times or 3 times, no problem. So okay, and then yeah, point is, it is your TL431. That's one cathode point is measure it with respect to that. Okay, I think so. This is your this is your cathode. You are getting VCC, that means B plus, and then this is your voltage divider. Your reference voltage is, oh, that means there you are getting PWM pulses, you can't measure it. Okay, and then yeah, you can't measure it. Okay, yeah, this is you directly connected to your opto isolator. You can see that your opto isolator one point is connected to B plus. This is your B plus. Yeah, this point you can see in this way. Yeah, this is your B plus, and this is a single-ended, that means single output SMPS. That means you are getting only around 10 nodes. This is a 9 volts SMPS. You are getting 10 nodes. Okay, that's fine. Okay, if you are apply your load, that may, this is a 10 volts is a boost up, that 1 volt is a boost up voltage by the capacitor. If you apply a certain load for that, that's come back. Okay, this point. This is your opto isolator. You can measure voltage across the opto isolator. That's you are getting around -1 voltage, -1 volt, not voltage. Yeah, volt. So if your current drawing is more, means your voltage may change across your diode, but you can't measure it that exactly. Why? Means that's immediate, that's a within a fraction of a second, that mechanism is auto mechanism that's going to set up their own build up. Okay, this is all about a simulation. Okay, and yeah, it's, I think so. So all test points are over. Okay, oh then yes, SMPS voltage testing. So I think this is enough voltage testing. And Oh, thank you for watching. Please subscribe Silicon Brainz team. Our link, you will get more videos about SMPS. And one more thing, please see my next session video. In that video, I am gonna give you few of the tips that was my experience, because the SMPS we can't tell exact problems because each person experience, each repairer experience is different. So please watch it. I'm gonna share you some of the points. Thank you for watching.